The next one you see C2H5OH, that's our solute, but this time instead of molality, we are given weight percentage, which is 5%. So we'll scroll to our page. Again, you see that we have a chart, and I like to assume always that I have a 1,000 gram solution, which is 1 kilogram or 1 liter. Okay? This just makes my life easier when I calculate molarity and molality, just simpler math. Okay, so we need to figure out how we can get this 5% into a usable number. All right, well, we know that percentage is going to be our moles of solute over, sorry, not moles, grams. Our grams of solute over our total grams times 100. Okay, so if we set this up and call our moles of solute, X will have 5% equals X, and then our total is going to be 1,000 plus whatever our solute is, so 1,000 plus X, okay, times 100. So we can just go ahead and divide that 100 out, and that'll give us 0.05 over here, okay, taking it back to decimal form. Okay, and now let's do some cross multiplying to get this stuff off the denominator. So 0.05 times 1,000 is going to give us 50. And then the x is going to be plus 0.05x. Okay? And that is still equal to the top, which was x. So if you subtract the 0.05, you get 0.95x is equal to 50. Divide by 0.95, and you get x is equal to 1.14. Okay, so that is our grams of solute. Okay, 1.14 because we're working with mass percent here. Okay, now we're going to take our 1.14 all right, and we're going to convert it to moles. So we need to do 1.14 grams, and then we'll want the molar mass of the C2H5OH on bottom, which is our 46.0609. Sorry, 0694. And that's 1 mole. Okay, so 1.14 divided by 46.0694 is going to give us 0.02. .025. Okay, so that is our moles of solute. Okay, And then our kilograms of solute, we're going to cheat. We're just going to use the calculation from before, so it's 55.51 because we're still using water, so no sense wasting our time if we don't have to. Alright, and then if we add that, we get 55.53 for our total here. Actually 5.4 if you round. Alright, and then this will give us 1001.14. Okay. Alright, so there's all of that. Alright, now we can start doing our calculations. Okay, so we already have our mass percent. So now let's look at our, let's look at molarity and molality. Okay, molarity is going to be our moles of solute over liters of solvent. So we got 0.025 divided by 1, which is 0.025. So that's easy enough. So we can just go put that one over here on our little chart. 0.025. Alright, and molality is going to be our moles, which is 0.025 over kilograms, and we have 1 kilogram, so it's going to be 0.025. Alright, now we got to do our mole fraction. Alright, mole fraction is going to be our moles of solute, 0.025, over our total, which was, okay, so there's our 0.025. And then our total was 55.54. Alright, so 0.025 divided by 55.54, and we get 4.5 times 10 to the negative fourth. Okay, so let's go add that to our chart back over here. Okay. Alright, and lastly we have our C12H22O11 with a molality of 0.5. Alright, so molality is going to be moles of solute over kilograms of solution. So again, we're going to have 1 kilogram, which is 1,000 grams, which is 1 liter. Okay? Alright, now we're going to go ahead and figure out our grams of solute. So we have 0.15 moles. Alright, and then we'll have 1 mole on bottom. And our molar mass of C12H22O11 on top, which is 342.3058. Alright, and once we multiply that, that's going to give us our grams. And we get 51.34. Alright, and again, we're going to cheat. We know that 1 kilogram is 55.51, which gives us a total of 55.66 for our moles of solution. Alright, and then 51.34 plus 1,000 is 1,051.34. Alright, now we're ready for our calculations. Alright, molarity is pretty simple because, as you noticed, it's pretty much always the same as molality because we're not dealing with high temperature situations. So we got 0.15 over 1. That's just going to give us 0.15 molar. So we can go ahead and add that to our chart back over here. Okay. And now let's work on weight percent and mole fraction. All right, weight percent is going to be our grams of solute. So that's 51.34 over the total, which is 1,051.34. And then we're going to times that by 100. All right, and we get, when we do that, 4.88%. So let's go add that to our chart. All right, and lastly, let's go finish off with the mole fraction of the final solution here. Oops, too far. All right, mole fraction final solution will have 0.15 over 55.66. Oh, crap, dyslexia kicked in. 0.15, there we go. 0.15 over 55.66. All right, this is going to give us our mole fraction, which is going to be 0.003. Okay, and that's the last thing we had to add to our chart. Alright, so it'd be good to look at the chart and get some comparisons. You see that molarity and molality are going to be the same because we're not dealing with solutions that are at high temperatures. And then you also see if they have the same molarity and molality, they're also going to have the same mole fraction. So the only thing that changed there was the weight percentage. So interesting things to look at.